Hello, everyone. This recording or session, I'm going to go over the quiz 4 problems with you on section 5.1, 5.2, and 5.3. So the first question here asks for us to convert the following angle from degrees to radians. Whenever you go from degrees to radians, you want to multiply by pi radians over 180 degrees. If you're trying to cancel degrees, you want to multiply by pi over 180 degrees so the degrees can cancel out. So if I have 205 degrees, I'll just put that over a 1. I'm going to multiply by pi over 180 degrees. And so the degrees would cancel. The pi is in radians. And I'm just going to go over and then use my calculator for that. Why not? Just to make it, right, simplify it for me. So if I do so I don't want to put pi. You can do 25. I can even do 25 over 180 and then have it simplify for me. I'm going to do 5 over 36. And so this is going to be equal to 5 over 36 with pi, right? Because I didn't put pi in because then that'll mess up my fraction. So it's 5 pi over 36. So that's what we're going to type in here. 5 pi over, oops, should put 5 pi. If you type pi, it'll give you the pi symbol. 5 pi over 36. Right, next, this is drawing the angle in standard position. So for this, you could use the unit circle. I put the unit circle in our, I think, week 4 folder where you need to draw the negative 30 degrees. So remember that angles open upwards from the x-axis. So in this case here, let me see if I can draw. The angle would be, right, over 30 degrees. I would open it as, right, that would be an angle that opens from the initial side to the terminal side. But because it's negative 30 degrees, I need to open the same direction downwards clockwise. So the negative 30 degrees is downwards from the positive x-axis, the initial side, then downwards. So it would be negative 30. So that would be B. And remember, quadrants go from 1, 2, 3, 4. So this would be in quadrant 4. Okay, next, we're going to find the positive angle less than 2 pi that is coterminal with the given angle. Whenever you have an angle that's bigger than 2 pi, we need to subtract 2 pi until it becomes less than 2 pi, because that's the given, right? It says if something that's less than 2 pi. Okay, so for that, you can do, and I know 23 pi over 7 is bigger than 2 pi because, right, 7 times 2 is 14, and 23 pi is bigger than 14 pi over 7. So I need to subtract 2 pi over 2 pi, and 2 pi, if I do that on the side, 2 pi over 1 is equivalent to, if I want common denominators, that's equivalent to 14 pi over 7, right? This is double 7. And so if we subtract 14 pi over 7, that'll give us 9 pi over 7. You could just also plug that into the calculator by doing 23 over 7 minus 2 and go to math, fraction, and it'll simplify to 9 over 7, but you just have to remember to put the pi back. And I know that's less than 2 pi because 9 is less than 14. So I'm just going to type in 9 pi over 7. Okay, number 4. Okay, this was one of the ones where we have to find the arc length of S on the circle radius R intercepted by a central angle. Theta, express arc length in terms of, let's see, what does it say in terms of pi? Then round your answer to the decimal place, to 2 decimal places. Okay, so I guess we need to know, right, what the formula is for the arc length. So that's going to be S equals radius times the angle theta. And one thing to note is the angle theta needs to be in radians. So if you're given degrees, the first thing you need to do is convert it into radians. Okay, so first let's convert 215 degrees into radians. And how do we do that? We multiply it by pi over 180 degrees. So let's do that first. I'm going to go to my calculator again and do 215 over 180. So that's going to give us 43 over 36 pi. Okay, so now I'll put in this formula. It says the radius is given that it's 3 feet. And the central angle, we've converted into 43 pi over 36. So this is the angle in radians. So if I put it in the formula, S equals the radius, which is 3. We're going to multiply it by 43 pi over 36. And I'm going to also do that using my calculator. I'm going to multiply 43 over 36 by 3. It's giving me 43 over 12, and I have to put the pi back. So this is equal to 43 pi over 12. So this wants the exact answer in terms of pi. And then I want 43 pi over 12 as a decimal. So it's going to be 11.2 decimal places, so 26 feet. Okay, the minute hand of a clock moves from, it says 12 to 11 o'clock, or 11/12ths of a complete revolution. How many degrees does it move? Through, or through how many radians does it move? Okay, to do this, you have to think about if it goes to 11 to 12 o'clock, or 12 to 11 o'clock, right? It starts here. It needs to go to 11 o'clock, right? That's 1. I'll put 3 here. Should have put 12 on the outside. 6 is here, 9 is here. So 11 is right here. So it's going to move, right, from 12 all the way around to 11 o'clock. So we're trying to find what's the degrees that it takes. Okay, so to do that, right, the whole way is 2 pi, or we're going to multiply 11 out of 12 because it's only moving from about 11/12ths of the way, right? Because it's the whole clock is in 12 parts, and your angle is only moving 11/12ths. So if we do that, we get, right, this simplifies to 6, 11 pi over 6. So that's the radians. For degrees, you could do the same thing. So this is radians. You could also convert that, or you could say, okay, what is 360 degrees? 11/12ths. Right, so then I'll just simplify that on the calculator. So if we do 360 times 11 over 12, oops, too many ones, we get 330 degrees. Okay, so I'm going to write 330 degrees, and here I'm going to put 11 pi over 6. Okay, let's look at number 6. Here we have, I might need more space for this. We need to use the Pythagorean theorem to find the length of the missing side of the right triangle, and then find the value of the 6 trig functions of theta. So in terms of theta, if theta is at angle A, right, it's right here, then we know that A equals 9, that's the opposite side. B, 12 is the adjacent side, and C is the hypotenuse. We don't know C, so we'll find C first by doing C squared equals 9 squared, which is A squared plus B squared, 12 squared, and C would just be the square root of that. So let's find that first by doing 81, or I'll just do 9 squared. 9 squared plus 12 squared, that'll give us square root of 93. Okay, and I'm thinking maybe 9 square root of 93. Wonder if it has a perfect square, probably not, but just you can check by dividing the 4, right? Because 2 squared is 4, dividing by 9. And so it's probably just square root of 93 for C. So if we, let's go ahead and label our C with square root of 93. So we know that this is square root of 93. Sine of an angle is opposite over hypotenuse. We went over that in the puzzle videos. And the opposite side is 9. The hypotenuse square root of 93. We need to rationalize by multiplying the numerator and the denominator by the square root. And this would be 9 square root of 93 over 93. Cosine is the adjacent over hypotenuse, so that'll be 12 over square root of 93. So if we multiply that by square root of 93, we get 12 square root of 93 over 93. Tangent is opposite over adjacent. And so that's going to be 9 over 12, because we can divide both the top and the bottom by 3. We can reduce that by 3 over 4. Cosecant is just the reciprocal of sine, so I can take sine here, so and do square root of 93 over 9. Secant is the reciprocal of the cosine, excuse me. And so cosine was originally 12 over root 93, so it can be written as root 93 over 12. I think I have to go down with cotangent. Before I do cotangent, let me fill up all the answers. So this would be square root of 93, and this was 9 square root of 93 over 93. Oops. Why isn't it going down? And this is cosine is the 12 root 93. Tangent is opposite over adjacent, so that was 3 over 4. Cosecant was root 93 over 9. And secant was root 93 over 12. Okay, and let me just clear this out because let's do cotangent. Cotangent is the reciprocal of tangent, so it'll be 4 over 3. Oh, I could check answer here. Let's. I wonder what this means, that my score is 28.57. Okay, well, let's finish the rest. Okay, cosine theta, here we have the acute angle is an acute, the angle theta is an acute angle of sine theta is 4 over 9. use the Pythagorean theorem, sine squared theta plus cosine squared theta equals 1. Find cosine theta. So for this one, I'm going to use the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. We're given that sine theta is 4 over 9, so let's do 4 over 9 squared plus cosine squared theta is equal to 1. 4 over 9 squared is 4 squared, 9 squared, which is 16 over 81, plus cosine squared theta equals 1. So I'm going to subtract 16 over 81 from this side, and that'll give us cosine squared theta is equal to 1 minus 16 over 81. I'm just going to have a calculator do that for me. And that'll be 65 over 81. Okay, so we're going to take the square root of both sides and get cosine theta is equal to square root of 65 over square root of 81. And square root of 81 is 9. So this would be square root of 65 over 9. Now, I don't think square root of 65 can be simplified because it's not, right, it can't be in a factor of a perfect square. So let me type that in. Yeah, use a calculator to find the value of the trig function. So cotangent remembers the reciprocal of tangent. So you don't have the cotangent button on your calculator. You only have sine, cosine, tangent. So to do this problem, we need to enter it as 1 over tangent of pi over 9. You have to make sure you're in radian mode. So whenever you're given cotangent, we type in 1 over, do 1. Oh, make sure we're in radian mode because we're given pi. It looks like we are in radian mode. So 1 over tangent of and then pi over 9, close. And that gives us round to 4 decimal places, 2.7475. So rounding it to 4 decimal places. Okay, let's look at what this problem says. This problem asks, find the measure of the side of the right triangle whose length is designated by a lowercase b. Round answers to a nearest whole number. So think about what angle you're given or the location of your angle. B, that's your adjacent side, and the 279 inches, that's your opposite, not opposite, I'm sorry, that's your hypotenuse. The opposite would be the other side, the hypotenuse. And which ratio, which trig function relates adjacent over hypotenuse? If I write so katoa, right? The function, the trig function that does that, adjacent over hypotenuse is the cosine. I'm going to write this as cosine of the angle, which is 55 degrees, is equal to the adjacent side. I'll write cosine theta is equal to the adjacent side over the hypotenuse. So the adjacent side is B, hypotenuse 279. To find B, I'm going to multiply both sides by 279 to cancel the 279. And so B is equal to 279 cosine of 55 degrees. Okay, so let's put that in. This time I have to make sure I'm in degree mode. I'm in degree mode, and now I'll put in 279 times cosine of 55. Now your calculator knows the 55 is in degrees. So now we got 160 point, it says round to the nearest whole number, so just 160 inches. Okay. Okay, number 10, use a calculator to find the value of the acute angle. So this time here, this problem, we're missing the angle, right? You're missing the angle. You're given the ratio. And so if you're missing the angle, we need to use the inverse function. To do the inverse, the angle is equal to the inverse of cosine 0.1607. We need to be in radian mode. So go back to your calculator and say mode, choose radian, and go to the main screen. So your inverse function is above your cosine, and we would do inverse cosine of 0.1607. And then that would be giving us the radian of 1.409 because it asks us to round to 3 decimal places. Okay, number 12 asks for, it's a telephone pole, and the angle given is right here. Here's the angle. And it says find the angle between the wire and the pole to the nearest degree. And the wire here, this part is 81 feet. And it also gives us this side, which is 60 feet. So in terms of the angle, right, we're given the hypotenuse side and then the adjacent side, because 60 feet is adjacent to the angle. Think about what ratio trig function relates adjacent with the hypotenuse, and that's cosine again. So cosine of an angle relates adjacent with hypotenuse. So we don't know the cosine of the angle, but we know the adjacent is 60, hypotenuse 81. Since we don't know the angle, we're going to use the inverse cosine. So inverse cosine of 60 over 81, and then type that into the calculator. And because we're in degrees, make sure you're in degrees again. I need to change to degree mode. And then if we type in the inverse cosine of 60 over, inverse cosine of 60 over 81, it'll give us 42 point, round to the nearest degree, so it's 42 degrees. Okay, which one's this? This one, says find the exact value of the 6 trig functions if we're given that the angle is at 8 and -8 is on the terminal side. So 8, -8, the point would be right here. The angle that you're referring to, right, would be this angle. And so you're working with this triangle right here. And so if you think about that angle, right, the x value would be 8. The y value is -8, and that's given. X is 8, y value is -8. And so in terms of x and y, what's sine theta? Sine theta in terms of x and y is y over r. So we actually have to find the radius as x squared plus y squared equals r squared. So x squared is 8 squared plus -8 squared equals r squared. So that's 64 plus 64. That's going to be 128 equals r squared. Take the square root, and we get r is equal to the square root of 128. I think we can split that up into square root of 4 and something else. Let's see here, 128 divided by 4 is 32. So actually we can divide out a 16. So let's divide the highest perfect square possible. Oh, we can actually divide a 64. Let's do that. And so that's half, right? So 128 divided by 64 is 2. So we could actually rewrite 128 as square root of 64 times square root of 2, which is 8 root 2. So I know r is 8 root 2. So y over r, y is given as -8 over radius, which is 8 root 2. So this would be simplified to -1 over root 2. If we rationalize root 2 over root 2, multiply that, gives us negative root 2 over 2. Cosine theta is x over r. X is 8 over 8 root 2. So that would be 1 over root 2. Rationalize by multiplying root 2 over root 2. We get root 2 over 2. Tangent is y over x. So that's negative 8 over 8, which is -1. Cosecant is just the reciprocal of, or the reciprocal y over r, or over r over y. And r is 8 root 2 over y, which is -8. So this would be negative root 2. Secant is the reciprocal of cosine. So that would be r over x. And r is 8 root 2. X is 8, so this would be root 2. Cotangent's reciprocal of tangent, x over y, which is 8 over -8, which is -1. So let's put all the values in. So negative root 2 over 2. Cosine is root 2 over 2. Tangent is negative root 2. Cosecant is just root 2. Secant is -1. And, oh, I think I did this wrong. Oh, tangent is, I skipped one. I wrote that tangent is y over x, it's -1. And then r over y, that was the cosecant, so that's negative root 2. Secant was positive root 2. I may be entering this wrong place, and this is -1. Okay, so 1, 2, 3, 4, 5, 6. Okay, number 13. Evaluate the following trig function and state whether the expression is defined. So for this one, you can use your unit circle, right? The unit circle that I've posted in the week 4 module. So secant 0 is, if you look at the angle 0, secant is going to be, let me rewrite it here. Okay, think about what secant is equal to. Secant is going to be, if we're working with the unit circle, right, it's going to be the reciprocal of cosine. And what is the reciprocal of cosine? That's going to be 1 over x. And at 0 degrees, 1 over x, the x coordinate is going to be 1, right? Because this is the xy value. So it's going to be 1 over 1, which is going to be 1. So let me just put that in here. Okay, find the exact value of the trig function. Sine of theta equals 4 over 5, and it's in quadrant 2. The placement of the quadrant matters. And so when you draw these, you have to draw them here in a coordinate plane. It's in quadrant 2, so it's in this quadrant. You always draw the angle. Let me pick a different color here. You draw the angle with the initial side on the x-axis. And because the angle opens this way, your terminal side is going to be out like this, and here's your triangle. So here's, we're going to label this as theta, and it says sine of theta is equal to 4 over 5. That gives you that the y value is 4, or the opposite side is 4, and your radius is 5. But we are given the y value, the radius, but we don't know what the x is. So we need to find that by doing the quadratic, the Pythagorean theorem. So if we do x squared plus y squared equals r squared, if y or x squared and we have y squared is 4 squared, r squared is 5 squared. That'd be x squared plus 16 equals 25. We subtract 16, we get x squared equals 9, and x equals plus or minus 3. You're going to say, okay, is this a positive 3 or is it going to be a negative 3? Because x, the placement of your angle and the triangle is on the negative side of the x-axis. We're going to say that x is negative. Okay, so that's why drawing the triangle in the right quadrant makes a difference. So what's cosine theta? Well, cosine theta is x over r, right? So x over r is going to be negative 3 over 5. What's tangent theta? That's going to be y over x. So y over x is 4 over 5. Cosecant, what's cosecant? It's the reciprocal of sine. So if sine is 4 over 5, I know it's going to be 5 over 4. Secant is the reciprocal of cosine, or you can even think of it as r over x, which is 5 over negative 3. Cotangent, you can think of it as x over y, or the reciprocal of tangent, so that's going to be 5 over I think I messed up with the tangent here. I think I read it wrong. Okay, so y tangent is y over x, so this should have been negative 3. I wonder if you've noticed that and then couldn't fix me because this is a recording. So this is x is negative 3 over y, which is 4. So we just need to put that all in, type it all in. Negative 3 over 5. Tangent is 4 over negative 3. Cosecant is 5 over 4. Secant is 5 over negative 3. And then cotangent is negative 3 over 4. Okay, I think this is the last one. The last one is find cosine of 7 pi over 4. So this, you can use the unit circle for this one. You want to go to 7 pi over 4 on the unit circle. The unit circle, 7 pi over 4 is right here. Okay, so if we go to 7 pi over 4, it's asking the x value, right? X is equal to cosine theta. So the x value at 7 pi over 4 is root 2 over 2. So that's all you need to type in for that. Okay, I'm going to submit my quiz. And so let's do that. I think I've submitted all the quizzes. Okay, so after you submit your quiz, because I allow you, oh, I've missed some. Let's go over. It's a good idea to go over the problems you missed. So let's see here. What problems I missed. So it looks like I missed question 4. It's always good to go back and you can always solve these. So let's see what I missed here. Wonder what I wrote. Okay, so I got 11.26. I may have copied down my, I may have had too many writings on the side. I believe I had 43 pi over 12 on the work somewhere, but I think I copied it down wrong before I multiplied by 3. So I think that's what happened. I think what happened was, right, I had s equals r theta, and I converted, trying to think what happened. I converted the angle. You need radians, and right now we're given degrees, and we multiply by pi over 360. Let me just do that real quick. So if we do, or we can even actually, yeah, let's just do that. If we do 215 over 360, and this is what you should do also when you take a quiz. Oh, I did 360. Oh my goodness. Sorry, it was 180. Okay, something wasn't looking right. This is what happens when you're taking the quiz real late. So if you do 215 over 180. Okay, that converts it to 43 over 36. And so I had that. And then what I remember doing is S equals radius is 3. And we need to multiply by theta, which is 43 pi over 36. I think I put in this by mistake when I had on the side, if we multiply that by 3, I do get 43 over 12, and I remember getting that. So I think the lesson here is make sure you enter in the right, correct solution. So I meant to put 43 pi over 36 instead of the 43 pi over 12 or 43 pi over 36. Let's go over the other one I missed. What was the other one? Oh, I got all of these wrong. We need to go over these again because that's important. I don't remember what I did. I honestly don't remember the work for this one. So let's redo this one. We had, we need to find the missing triangle. I wonder how I got 93. Okay, let's do this again. So we have a squared plus b squared, which is c squared. A squared is 9 squared. B squared is 12 squared. We get c squared. And we put that in the calculator. We have 9 squared plus 12 squared. Okay, I'm not sure how I got 93. I might have to look at the recording again. I apologize, and I bet some people have noticed, but the one downfall of online classes is when students see me make mistakes on the board, they can catch me, but you guys can't tell me directly in time. So if we take the square root of 225, that's going to give us 15. Okay, that works out much better. I'm still not kind of curious how I got 93. So we have 15. And so C is the hypotenuse, A is the opposite side, B is the adjacent side. So if we go over, now we have the answer, so that helps. Sine is opposite over hypotenuse. So that would be 9 over 15. And if we simplify that, divide by 3s, we get 3 over 5. Cosine is adjacent over hypotenuse. And that's again 12 over 15. If we divide by 3, we get 4 over 5. Tangent I got right. That's interesting. Cosecant is the reciprocal of sines, or 5 over 3. So that's how you get the cosecant there. And then secant is just the reciprocal of cosine, or its hypotenuse over adjacent. So that would be 5 over 4. Cotangent is whatever your tangent is reciprocal. Okay, so this is good. You should always go over the quiz and see what you missed. And, if you can always retake it for a higher score. Okay, so again, sorry for the mess up there. I still don't know how I got square root of 93. I think I have to watch the recording to see how I got that. Yeah. But another lesson is don't do this late at night when you're tired. Okay, so I hope that was helpful. Again, you can use your unit circle. I'll put the unit circle. I already put it up, and you can also use a unit circle on a quiz or even our next unit exam. Okay, let me know if you have any questions about the quiz or anything from this week. And I hope you have a great week and weekend.